Lesson 9: Distance, Time, and Speed on the Earth's surface. To begin this lesson, we shall discuss the nautical mile, the length, distance of the arc of a great circle which subtends an angle of 1 minute at the center of the earth is called a nautical mile. From the above definition, it implies that 60 minutes will complete 360 degrees. That is going around the great circle. That is the circumference of the earth, equal to 2 pi arrow, the radius of the earth. That is the circumference of the earth. To convert this to nautical mile, you multiply it by 60 minutes and you have 21,600 nautical miles. That is 2 pi arrow, that is equal to 360, is now equal to 21,600 nautical miles. If the radius of the earth is 6,400 kilometers, 1 nautical mile is equal to circumference of the earth divided by 21,600. If you replace pi with 22/7 and radius of the earth with 6,400 kilometers, you have this result. You can bring 7 down to meet 21,600. After multiplication and division, you have 1 nautical mile approximately equal to 1.86 kilometers. Therefore, 1 nautical mile is equal to 1.86 kilometers. A speed of 1 nautical mile per hour is called a knot. It is widely used in air and sea navigation. Recall that speed is equal to distance over time. The earth makes a complete rotation about its axis every 24 hours. This implies that for any 2 meridians that are 15 degrees apart, the difference in time between them is 1 hour. This is the meaning. To get this 15 degrees, if you divide the complete rotation 360 degrees by 24, you have 15 degrees. So for every 15 degrees, you have 1 hour, and so on. 2 meridians 1 degree apart will therefore experience 4 minutes time difference. 2 meridians 1 degree apart will experience 4 minutes time difference. Places in the east will experience noon when the sun is supposed to be overhead earlier than places in the west. Examples number 25. X and Y with the given longitude and latitude are two places on the surface of the earth. If the local time at Y is 3 p.m., what is the local time at S? Solution: to get the local time at S, we need the time difference between the two places. So we need the angular difference between S and Y and convert it to hours. The two places are on opposite sides of the prime meridian. Their angular difference is through addition. You have 60 degrees. Earlier, 1 degree is equal to 4 minutes. For 60 degrees, you have 60 times 4 minutes, that is 240 minutes. If you convert this to hour, using 60 to divide it, you have 4 hours. Since Y is eastward of S from the question, Y is on the east side of S, its time is ahead of that of S. Places in the east, they are ahead of places in the west. Now, the local time at Y is 3 p.m. and the time at Y is ahead of that at S. So you are to move backward 4 hours in order to get the local time at S. And when you do that, the local time at Y, the local time at S will be 11 a.m. because the time at Y is ahead, 3 p.m. So you go backward by 4 hours, the time difference between the two places. When you go back by 4 hours, the local time at S will be 11 a.m. Example 26. P and Q are two places on the Earth's surface. Given that Q is due east of P and that local times at P and Q are 2 p.m. and 7 p.m. respectively. If P is on longitude 10 degrees east, on what longitude is Q? Solution: time difference between P and Q is 7 p.m. minus 2 p.m. and that is 5 hours. If you convert it to minutes, you have 300 minutes. So we have to convert this one to angular difference for us to determine the longitude of Q. Previously, 4 minutes is equal to 1 degree. To convert 5 hours to degree, first you convert it to minutes using 60 to multiply it. You have 300 minutes times 1 degree divided by 4 minutes, and that is 75 degrees. The angular difference between P and Q. Hence, if P is on longitude 10 degrees east and Q is eastward of P, that means Q is ahead of P. Q is ahead of P. That implies that the longitude of Q is going to be higher than that of P. To achieve that, you simply add the angular difference to 10 degrees east, and you have that the longitude of Q is equal to 85 degrees. In other words, P and Q are on the same side of the prime meridian. Their angular difference is through subtraction. Hence, 85 degrees minus 10 degrees is equal to 75 degrees. You see why you need to add 10 and 75 in order to get the longitude of Q to be 85 degrees east. Example 27. Point P with latitude 36 degrees south, longitude 120 degrees east is a point on the Earth's surface. Q is another point 840 kilometers due east of P. T is a point 840 kilometers due east of P as well. Calculate correct to 2SF. A, the radius of latitude P. B, the latitude of Q. C, the longitude of T. Take pi equal to 3.142, radius of the Earth equal to 6,400 kilometers. Solution: radius of latitude is given by this formula. Alpha, the angle of latitude for point P, is 36 degrees south. That is, alpha is equal to 36 degrees. Radius of the Earth is equal to 6,400 kilometers. You have it in this form, which simplifies to this, to 2SF. The radius of latitude P is equal to 5,200 kilometers. B part of the question: find latitude of Q. By default, let the latitude of Q be S degrees north. By default, we have the upper side of the equator. Let the angular difference between P and Q be theta 1. Now check point P. The latitude is 36 degrees south, and point Q, the latitude is S degrees north. They are on opposite sides of the equator, so their angular difference is through addition. So theta 1, the angular difference between P and Q, is equal to S plus 36 degrees. Distance between P and Q is given to be 840 kilometers in the question. Now, the distance is along great circle. So distance PQ is equal to this. The distance is given to be 840. This is the angular difference over 360 degrees times pi times 2 times pi times radius of the earth. If you make this term the subject, first multiply through by 360 to clear fraction, you have this result, and divide both sides by the product of these three numbers to make this term the subject in this form. When you multiply, you have it in this form. After division, you have s plus 36 degrees equal to 7.519 degrees. To get s, you transfer this term to the right hand side. You have it in this form. When you subtract, you have minus 28.481 degrees. To the nearest degree, you have 28 degrees minus 28 degrees. Latitude and longitude cannot be negative. So S is equal to minus 28 degrees north. For you to convert this to positive, there is always change in the direction of the north to south. Therefore, latitude of Q is 28 degrees south. C part of the question, we are to get the longitude of T. P and T are on the same latitude. That means their distance is through a small circle. Then P and T are on the same side of the prime meridian. So let the longitude of T be h degrees east. H degrees east. Let the angular difference between P and T be theta 2, since they are on the same side of the prime meridian. Their angular difference is through subtraction. Then alpha is 36 degrees. P and T are on the same latitude. The distance between P and T along the latitude is 840 kilometers. Such a distance is given by this formula. The distance PT is 840. This is the angular difference in terms of longitude over 360 degrees times 2 times pi times radius of the earth times cosine of the angle of latitude. To make h minus 120 degrees the subject, multiply through by 360 to clear fraction and divide both sides by this product. You have it in this form. When you simplify both numerator and denominator, you have this result. After division, you have 9.294 degrees. To get h, you transfer this term to the right, it becomes positive. After addition, you have this result. To 2SF, you have 130 degrees. Hence, longitude of T is 130 degrees east, because they are on the same side of the prime meridian. So T is due east of P from the question. So you have the east added to 130 degrees. Example 28. An aircraft took 2 hours to fly from a town P, latitude 65 degrees north, longitude 45 degrees east, to another town T, latitude 65 degrees north, longitude 15 degrees east. The aircraft then changed its course, and 9 hours after leaving T, arrived at a third town, latitude 0 degrees, longitude 15 degrees east. If the flight from P to T was along the line of latitude, that is Moseko, and that from T to Q was along the meridian, Great Circle, calculate correct to 3SF. A. The total length of the journey. B. The average speed of the aircraft. Take pi equal to 3.142, radius of the earth equal to 6,400 kilometers. Solution. A part of the question. Total length of the journey is the distance PT along parallel of latitude plus distance TQ along Great Circle. Distance PT is given by this formula, where θ1, the angle of longitude, is 45 degrees minus 15 degrees. They are on the same side of the prime meridian. You subtract to get their angular difference, and that is 30 degrees. Alpha, angle of latitude, is equal to 65 degrees. You replace the various parameters with what they stand for in the given formula. You have it in this form. When you simplify and divide, you have 1,416.391 kilometers as the distance between P and T. Distance TQ is along Great Circle given by this formula. θ2 is equal to 65 degrees. You replace θ2 pi and radius of the earth with what they stand for. You have this expression. After multiplication and division, you have the distance to be 7,261.511 kilometers. Total distance becomes the addition of the two distances in this form, and you have it to be 8,679.902 kilometers. To 3SF, you have it in this form. B part of the question. Average speed is equal to total distance over total time. Time for the whole journey is 2 plus 9 from the question. You have 11 hours. And the total distance is this. Therefore, average speed is equal to total distance over total time. You have it in this form. To 3SF, you have 789 kilometers per hour as the average speed. End of lesson 9.